It's about to start. We'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound check, camera check, lights check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is the data bender. In case you are new to this project, we have been working on several projects here on this series of streams. The data bender is this project that allows you to just throw any kind of media file, like a video, and it will convert the bytes, it will interpret the bytes that make up the file that is the video. It will interpret those bytes as if it was audio, apply some audio effects like a phaser, pitch shifter, or something like that, and then display that as video, the result of applying an audio effect to the bytes that make up the video, and that it will show you that to you. And in particular, what we are going to do today is first clean up all the loose threads from last time. We are going to organize things a little bit, and then we will try and do data bending with different pixel formats, different audio formats. So we are going to add even more bends to the mix. Right now, we have explored all the different kinds of filters that come with FFmpeg, which is the tool we are using to do all the data bending stuff. We will now look into different pixel formats, audio formats, and different sample rates, all those things that will make the results even more interesting and unpredictable. So let's start with the organizing the mess. So here's what I mean by the mess. We have the source for the project, which is going to be able to apply random data bends to a given file. We sort of modify this source to do a hacky exploration of all the effects that or filters that FFmpeg comes with. And last time I was just modifying the code and thinking, do I want to keep this or not? And I decided that I do want to keep it. So we are going to adapt this in such a way that it is capable of doing this exhaustive exploration of all the filters, if that's what we want to do. And it will also be able to do random filters. And then after we have some infrastructure for this, then we will explore pixel formats and whatnot. So in essence, we have these changes that I haven't committed. I sort of want to change the code so that it has both the thing that was there before as well as the thing that we added. And we could come up with clever abstractions for how to do these things, but I think that maybe copy and paste will be better for this. I'm a big believer in copy and pasting, in case you haven't noticed. So how about we have this bends variable that gives you the number of bends that you want to do. And then on the command line, we get that as a number. And then we convert that into a number. How about we have, besides just a number, If you give it a number, which is the default, it will do that number of random bands, but then we will also have options, maybe hidden options or undocumented options, internal options, mostly for our benefit. These options will be not a number, but something like filters. Yeah, that's what we'll do. So here I will say that if bands is audio filter, not just filters, I guess. Why are you complaining? Oh, okay. So if it is of type string, well, I guess let's say if it is not of type string, then undefined. Otherwise, yeah, like that. That should do it. So if the type is not string, then return undefined. If the bands are filters, then just pass that along. Otherwise, convert that into a number. And then it is complaining now because the type of bands says that it must be a number, but it may also be something like filters. And now it stopped complaining. Well, it should have. Oh, it doesn't know how to do. It doesn't know how to do narrowing in this situation, so it's still complaining. What if I am silly and explicit? Does it know how to narrow the type now? Now it knows. Okay, I will be silly and explicit. Oh, hello. Hey, Tail. Hey, Ben. Yes, my my beard is gone. So my relationship to the beard is that I don't like it, but it grows. So when I'm feeling good about myself, when I want to restore my energy, I trim it. So I guess it's the opposite of that biblical character whose name I forget, whose strength is their hair or their beard or something. I don't know the Bible that well, I think. But anyway, there is a Bible character whose strength is their hair somewhere. I'm the opposite of that. When I cut the beard, when I trim the beard, that's when I feel good. And also, yeah, Christmas is over, but as I just demonstrated, I am not that into the Bible, so I'm not that into religion. I am not that into Christmas. And I'm not that into Santa either, I don't think. Anyway, it's great that you are here with me. I hope you enjoyed the ride. And yeah, so now we have this situation where, well, because we are being silly and explicit here, we might as well just do it like this, which I think is more straightforward anyway. So if the bands is filter, pass that. If it is a string that is not filters, convert that into a number and pass that. Otherwise undefined, which will make the function use its default, and that is to do 10 random bands. So now the bands can be this filters situation. And that is going to be the flag we are going to use to find that you are interested in doing an exploration of all the filters. So now I'm thinking that maybe the easiest way to go about this is to copy and paste this into another buffer and then revert the changes using Git, because we are in a bit of a mess here. So what I'm going to do is take the whole body of this function, copy that into a separate buffer, then using Git, I will revert some changes. Not all the changes, but many of them down here, and then revert those. And then I do want to keep this, I think. We have to think about that. Do we want to keep this? What this is doing, by the way, is if you're trying to run an ffmpeg command and it takes longer than 30 seconds, it bails out. And I think that we may want to keep this, actually. The reason why this was here in the first place was that we were exploring all the different filters. So some of them would time out. Things like clip was super slow, so it would time out. But I guess that in general, when you're using this tool, I guess let's say that we are going to be a bit more generous, because depending on your machine, ffmpeg may be relatively slow. So 60 seconds. If it takes longer than 1 minute to do something, bail out. Okay, so we're going to keep that. And now this code is in a state that should work and should do temp random bands, but not using all the filters, using these filters here, or I should say not using the filters that we found to be good, just using filters, whatever filters we found in 2 coding sessions ago. Let's see how this goes. I'm going to delete everything that is in the examples folder. And there is a syntax error. Is there a syntax error? I don't see a syntax error. You're expecting me to close a brace. Oh, this function definition isn't closed. It's probably because of me goofing up on the Git revert. How about that? Take this. But this is a bit odd, because this was supposedly working. Let's use a Visual Studio Code feature that I don't use often in the streams, but it's super useful. It is folding. So you can pay attention here to the top if you want to learn about the keyboard shortcuts I'm using. This folds the entire block recursively. And this unfolds one layer of the block. And with that, I can explore not from the top down, but from the outside in. And this is going to help me find whatever problem there may be in terms of closing braces and whatnot. It seems to me that the function definition ends where it should. But where are my auxiliary functions? They are in the loop. That doesn't seem right. So I think that there should be a closing brace here instead. This for loop wasn't closed. Odd. Let's start the exercise again, fold the whole thing, unfold. And now this looks more sensible. So we check for the existence of the file. We check that the file has an extension. Then we get a hold of the metadata. We create the output directory. Then there is this big regular expression to deconstruct this text or to parse this text. Then we do a bunch of data bands. This is the part where we want to check if the bands is a number. This should give an error because band is a number, but this bands variable could be a string. Why isn't TypeScript complaining about this? I'm comparing a number to a string. Of course, in JavaScript, this is something that works because JavaScript can do anything to any kind of value. But TypeScript was supposed to warn me about this. Anyway. Then here in FFmpeg, all that looks good and the timeout looks good. Yeah, I am not sure why this was missing. It was this closing brace that was missing. And then here in the body of the loop, we convert from your input file into a raw input file, then filter, then convert back into a sensible format instead of raw, and remove the raw stuff. Yeah, perfect. It was nice that this allowed us to review the high-level overview of how things work, but it is a bit odd that this was missing. But anyway, I will take it. This should work now. It seems like it did until it crashed because probably tried to apply a filter that isn't allowed. Shouldn't be allowed. What is the error here? Was it waiting for my input and timed out? I guess I'll just try to rerun this. It should work. Samsung, yeah. I should know that. There is a great song by Regina Spektor with that name, yeah. This song is awesome. Conversion failed. Oh, god damn it. It seems to me that we have this code working, and then I looked the other way and looked again, and now it's completely broken. What the hell happened? What is even the command that is failing? Let's look at the logs. So it produced a couple data bands, and then it failed. So yeah, this indicates to me that it tried to do some kind of band, some kind of audio filter that doesn't work. Yeah, error initializing filter. Yeah, that's okay. That's the kind of error that we expect to see. And it is bending stuff. This is what we like to see. This is what we are here for. So, okay, the code is not completely broken. How about we do a couple things. Over here, when we have that loop, oh, okay, so last keyboard shortcut you can learn about folding is the one that I just ran to unfold everything in the file. So over here is where we have that loop to do a number of data bands. Now we have to check the bands, and in case that it is filters, we will want to do stuff, and in case that it is a number, so I guess the default case, should I put a break on the default case? I feel silly doing that, but for consistency, I guess I will. Anyway, so this whole loop will happen in the default case. And over here on this case for the filters, I'm going to start borrowing stuff from this buffer that we collected before, and that is the code we wrote to explore all the filters. And it starts to get interesting around here. And it stops being interesting there. And there is something else I'm going to do about the syntax of this case expression. I'm pretty sure we will want to define variables with the same name in other cases. So imagine that there is a case called pixel formats, for example, and then we would like to perhaps have an audio format variable there. This conflicts, but if you put braces around the cases, then it works. So that's what we are going to do. And I tend to avoid putting the braces around the cases unless the cases are super long, like these are. In that case, I put the braces so I don't have to worry later. Though it will be a syntax error. TypeScript will tell us about it. It's not a big deal, but anyway, put the braces in there. When it's not necessary, I tend to avoid putting braces. For instance, here you can see that because it's a single expression, I don't put the braces, and I am aware of the potential problems in this. There was a famous Apple come on, go to fail, yeah. There was this problem, security problem, super deep security problem that had to do with this, not putting the braces. And I'm aware that this could happen, but in practice, I do use things like prettier, and I do run prettier as part of my test. So if the code looks like this, so it looks like this is part of the if when it isn't, then this is going to be a prettier error. So I don't worry about it too much, and this cleans things up. There is less punctuation in the code, and I appreciate that. In C++, I do always use break in the default case because I might add another case below at some point. I don't know if this also applies to TypeScript though. Interesting. I didn't know that you could do that. I thought that the default case would be a catch-all and then it would not even try to do anything to cases below. Now I'm curious. How does that work in JavaScript, and how does that work in C even? Let's start writing some JavaScript. So if I understand you correctly, you have a case of 2, and you shouldn't see this. Then a default case. And then a case of 1 that should match. I guess I will just console log 2 here. So what we should see is just the default. Wait, what? I thought that the switch statement was going to check the subject against the cases in order, find one that matches, and then bail out. That's not what it does. It finds all the cases, matches against all the cases, and I must assume that it does that in order, but I don't think it matters because there is no way for it to have side effects here. Can you have expressions here? You can have expressions here, can't you? God damn it. Yeah, so this could be an expression, which means there could be side effects. I must assume that it's doing from the first down. Really hope so. Anyway, it tries to find a match, and only if it can't, then it will go to the default. That's fascinating. So if I didn't have a break here, it would find that this is what it needs to run, but then it would also run this because the cases fall through. Fascinating stuff. All right, yeah. Thanks for the teachable moment, Tail. I always learned so much from you. In C, the order of cases doesn't matter, but of course C only supports compile time constant numbers. Yeah. Okay, that makes sense. I didn't know that about C. I thought that in C I could put expressions in that position, in the case position. Ah, yeah, okay, so it wants to resolve the jump table statically. And it seems like in JavaScript it is resolving that dynamically. Well, it's probably gonna find a way to do constant folding on the 1+1 that I had. It's probably gonna fold that constant and just in time compile that into a jump table. But yeah, I get what you mean. Anyway, where were we? We were in this situation where I was writing, and yes, I would adhere to the notion of putting breaks at the end of every case, but I will also only add cases above the default because I don't like the way that default being in the middle looks. It just doesn't look right. Anyhow, so if we are exploring the filters, this is the code that we wrote in the last session, and this fixes the pixel format, audio format, sample rate, channel count, all of that to this so that only the filters vary. And then it converts into raw just once, which is faster. Then it goes through all the filters, and I am going to do something about this list, which is to sort alphabetically. I don't know why I didn't do that before, but I'm going to do it now. Before it was in the order given by FFmpeg when you FFmpeg filters, when you list all the filters like this. It was in that order. Now it's in alphabetical order, which I think makes more sense. And then let's see. To do use different inputs and output settings. This to do doesn't apply in this case. And I think I'm gonna keep this because this is sort of a hidden flag anyway, and it is kind of useful to have this. And then at the end of the loop, it removes the files. And I will put a new line before the break. I'll put a new line before the break here as well. All right. So now to put this to test, the fun thing is that every time I was saving, this was running on the background. Let's remove all of these. Let's stop what was running. And this time, I am going to, I guess, first commit what I have, because what I have is essentially just a copy and paste. Should be working. And then I am going to see how we are calling this. And the number of bands will be filters. This should trigger the situation where we are doing all the filters. Oh, it does not work like that. Bands, filters. All right, yeah, that looks good. Okay, I'm gonna stop this now because it worked. And it is logging just the commands that it ran. I'm okay with that. Cool stuff. This may be useful later when we want to do some kind of list of all the filters and what they do. I guess we are sort of doing two things here in this project overall. One thing is we are building this tool that is going to help people who want to do data bending but may not necessarily be super well versed into FFmpeg and videos and output and videos and audio formats. So that's one thing we are doing. The second thing we are doing is we are curating good bends. We are finding bends that work well. It's a much harder problem, in fact, as it turns out. And this second thing of curating bends that work well and whatnot, this is sort of what you can do with this flag. And that's why I decided to keep it. Because in the future, if you come up with new filters or whatever the case may be, it's relatively straightforward to document everything that works, that doesn't work, and why. Awesome. So what's next? I guess I can get rid of this buffer. And now I think I want to look into what we have on the README, which is this table that we compiled last time of all the filters in FFmpeg and whether we liked what we saw. This is going to be the list of filters that we actually want to use when doing the real bends, which is what we do over here. So let's get rid of this list of bends. And get this list of bends. I am going to sort this alphabetically, and I am going to commit this going to get a copy of this table, put it in a buffer, find all the places where we have this, which means either the thing failed to run at all, or it timed out, or it, which is another way of failing to run, or it wasn't interesting. I'm going to select all of those and remove them. Now we have only bands that we found interesting. So I'm going to copy this list. And drop it here. And I will leave myself a to-do here, which is include filter parameters. It could be the case that even the uninteresting filters were perhaps interesting given interesting parameters, but what I decided last time, and I maintain this decision, we have so many interesting filters that let's not bother with the filters that are uninteresting. But even in the interesting filters, like a compressor, we have plenty of options in terms of like threshold, attack and release, and so on. So we could play with these parameters to make the bands slightly different every time. So that's what I am going to do here in the future. Now let's run this and see the bands that come out. One important thing is that this should not fail. Previously, it could be the case that we would use a filter that would throw an exception, but now this should no longer happen. Yeah, right. I'm positive about what I said. Let's get rid of any remaining bands. There are none. And run this. Now we should get 10 bands. All of them should be interesting. None of them should throw an exception. Not was one is here. Hello. Great to have you here. I hope you enjoy this. It is the last stream of this year. Okay, it seems like the program finished running. And we do have 10 bands. And it finished running with a clean exit, which means no bands failed. And we can see that there are 10 of them, and all of them should be interesting. And when I say interesting, I just mean they don't look exactly the same as the input, which is this. Okay, so let's look at 2. Yeah, that's interesting. I guess that's interesting, but I don't really understand what happened here. The thing is, we explored all these filters with a fixed pixel format, audio format, and so on. But when we are actually using, we pick from different audio formats, audio sample rates, and so on. So the combination of the filter and different audio formats may be wacky. But I guess that's kind of the nature of the game, and that's why we do 10, because one of them is bound to be good. The thing that I do not want to see is just the same as the input. And this one is amazing to me because if you look at every frame, the edges, or I guess if you look at the first few frames, the edges are relatively sharp. But as you go on, you can start to see the blockiness that is coming from the, I can only assume, from the encoder. When we encode the raw back into an MP4, we are encoding into an H.264 codec format. And the blockiness, I guess, is coming from that. This one is not terribly interesting, but it's not terrible either. Especially when we add more parameters to this. Ah, this one is nice. And I think it would be awesome to take the original, take the bend, and in a video editor, fade from one to the other. Or cut really fast between data bends. And naturally, if you look at a band and you're like, oh my God, I love this, I need to know what generated it, you can always go to the log and find what generated 9.mp4. This is the transcript of the commands that were run. So you could even copy this and paste it on the command line. And it will work. It will create the same file, unless there's something non-deterministic about the filter, which I guess is not the case for most filters, I think. I don't think we're like adding noise or something. Oh no, this is what I didn't want to see. Yeah, this is uninteresting. It didn't do anything. What was 10? 10 was a supercut. Let's rerun this. The filters, the thing that explores all the filters, let's rerun this, but let's only run a supercut. Interesting. It seems like a supercut gives you interesting results when you're using this particular pixel format. What is the pixel format? This pixel format, this audio format. In that case, a supercut is interesting, but in this case, it is not. Let's look at the differences between the interesting version and the uninteresting version. This is using RGB 24. This is using a RGB 24. So the pixel format is not to blame. This is using a law, that's using a law. This is using a sample rate of 48,000 and a sample rate of 8,000. This is using one channel, this is using two channels. Interesting. Maybe we should cut this sample rate. And I admit that having to come into the code and comment things out and whatnot is not the most ergonomic way of going about this, but for our little exploration, I think it's good enough. We could have a more sophisticated setup in which you could say exactly what filters to run and whatnot. But at that point, just run ffmpeg on the command line, I guess. You know what I'm going to do? I think I'm just going to not use a supercut. I'm not even sure what it is at all, actually, because a Superpass, I guess, is an equalizer that is a high pass filter. And this is probably a low pass filter. But what's the difference between stopping and cutting a frequency? I don't know. Whatever. I just removed it. It is what it is. So with this in place, how about we explore different pixel formats? What I am going to do is I'm going to pick one of my favorite and also fastest of the filters, and I'm going to apply it to all different pixel formats. Yeah, that's what I'm going to do. Let's do the setup for the code first. I will add an option that is that. Then on the type, that. And then this stopped complaining. Perfect. Then I will find that switch case. I will borrow the case for the filters, and I will duplicate that. And then in this case, I will have a filter that I really like. And here I will have pixel format. And this conversion will need to happen in the loop. Which means that this removal will need to happen in the loop. No, not really. You can just overwrite while in the loop, which actually makes me think that we could do all of this input and output removal at the end. Yeah, we should do that. But one thing at a time. What is a filter that we liked? I think that there was one related to tempo that was good, but it is kind of slow. Well, whatever, I will take it. Now let's have a list of all the pixel formats. In case you don't know PB copy, it is something that takes the standard input and puts that in your clipboard so that you can paste like this. Paste into a buffer like this. So I'm only interested in formats that allow me to go in and out. So I will only find formats that have both in and out like this. I will select all the lines that have this IO, and I will go to the beginning of the line, the end of the line, cut. And then we have all the pixel formats that have input and output support. Just like that. Hang on, we have a file called stuff. Oh, that's just filters for the time being. We should sort this alphabetically. So instead of calling it stuff, I should be calling it filters. No, I will put more stuff here later. And I will also sort this alphabetically, I think. I realized that they were sorting by relevance, and that's why YUV420P was at the top. But I'm going to sort everything alphabetically for my own sanity. And with that, let's commit what we have and review this code, because I think there are things we can extract. There is a bit of repetition that we can extract. I find myself very silly writing things like this. I understand the necessity for the type system to pick it up, but the type system could be aware of the includes as long as all the constituents are literals. It wouldn't be terribly difficult to do it, I don't think. Well, these things always turn out more difficult than you would expect. Anyway, let's go to that switch statement, and what we will do is try and find similarities at the top and at the bottom. So over here at the top, we do have this, but that's a coincidence because it is just fixing the parameters that don't matter for this specific case, but it's always different. So I'm not going to change that. Or maybe I will. So check this out. I can extract this up. And if one of these needs to overwrite something, so for instance, the filters will overwrite with this variable by shadowing. Not sure I love shadowing this way. It's kind of hacky, but it does clean things up a little bit, so I'm going to go with it. Then the input and output raw file names are always the same, so I can cut that from there. And then we have this optimization that we convert things only once when exploring filters. But this optimization is only possible because we are not touching the frame rate, pixel format, size, and so on. And that is sort of a special case, which is fine, but I think I'm going to be consistent and put this here. Yeah, you are going to be doing some extra work when you're exploring different audio filters. You are going to be converting the same file over and over unnecessarily. It is what it is, I don't care. So now we have a case of filters. You go over all the audio filters. A case of pixel formats. You go over all the pixel formats. That is looking okay to me. And because we have a for loop, we don't need these braces anymore. Anything that we bind will be in the scope of the for loop. And that saves one brace. Then at the end of all of these, at the end of the pixel formats as well, I have this line again. So let's remove this line from here. Let's remove this line from there. And find the end of the whole switch statement and put the removals here. We also need to remove this. Yeah, we made many cosmetic changes, simplifying the code. It's going to pay off. It's going to be great. So now when you look at the thing that explores audio filters, for instance, right next to the thing that explores different pixel formats, they are just a for loop over the thing that they are interested in, converge. These lines are the same. These lines are the same. All of this is the same, but this is going to be different. There may be some way to abstract this and remove this repetition, but I'm not going to go there now. Now let's compare these with the default case. It should be just a for loop and a break, and it is. And I'm going to move these lines down so that they happen after the conversion from raw. Or maybe not. I think I'm going to move these lines down so it better matches what's happening here. And I bet that these lines have already occurred above in exactly the same way. They have. So these lines can be removed. Yep, this is looking good. Now let's do the same to the filters. And check again. Let's check again that I didn't mess with anything. When I am exploring filters and when I am exploring pixel formats, what does the code look like? A for loop overriding, shadowing that variable from above. Then these lines change, because here I'm interested in the pixel format. Then this line, I want that to appear here. Like so. And the left and the right are looking more and more alike, as they should. And this, I'm not interested in the audio filter, I am interested in the pixel format. And then this looks like that. Let's check that the order of the formats is the same as here. Pixel format, audio sample rate, audio channel count, audio filter. All of that checks out. Awesome, yeah. The code is looking clean. And I suppose we have what we need to test the different pixel formats. Yes, it looks like everything is okay. So with that, let's npm run prepare and, or actually let's look for bands. Yeah, that. npm run prepare, and this time we are exploring the pixel formats. And it is off to the races. Awesome. While that is running, Mage is here. Hey, Mage. It's great that you're here now. Thanks for joining us. Do you want to look at some data bands with different pixel formats? Do you all have any intuition before we actually do this? We saw that the filter that we are using is super interesting. Looks cool when you use RGB24, which is probably the most straightforward pixel format, where you have 8 bits for R, red, 8 bits for G, green, 8 bits for B, blue, making up 24 bits RGB24. But all these wacky pixel formats, I think, they will have super different results. The same filter applied to the different pixel formats, I think, will yield incredibly different results. But I don't know. Do you all have an intuition for this? What do you think? Do you think that we are going to see the same thing over and over? Or do you think that the pixel format is going to make a big difference? That's what we're about to find out. I like what this is doing. What? Why did it turn red out of the blue? Out of the red, I suppose. This is so fitting. Check the video. The video is a silly video that Arya and I are working together on. And it is this strange song, experimental, gets super crazy. And what I am actually playing on the melodica is... it isn't even on a scale. It's kind of a crazy song. And I look like I am going crazy in the footage. That's what I was going for. And precisely when I do the creepy eyes, the footage turns red. How does it know? This is amazing. Now let's look at another one. Okay, this is similar so far. Do we get the red artifact? We do. What the hell? And these are RGB and GBR, so it's not terribly surprising. I suppose that these are the same, just reversed. And this is still looking the same. I suppose that this is probably going to be similar to that, except with an alpha channel, so I don't expect that to have surprising results. But this one I expect to be different because this is not using RGB, it's using YUV. And it is different. But less interesting, I suppose. This is probably going to be similar to that. Does it have the red artifact? It does. If you are watching this and you can explain why the thing is turning red, and it's not just one frame either, it turns red after a couple of seconds, and then it is red for several frames. If you know why this is happening, I'm all ears, because this is crazy to me. That's lovely. Oh my god, that looks like a halftone image. Do you know what I'm talking about? The kinds of pictures you find in newspapers. Like this. Images that are made out of dots. This is crazy. I love this one. And it goes all over the place. Oh, this is paying off. This is similar to the other one, but less pronounced. It's still giving me that halftone kind of feel to it, which I am super happy about. Ooh, this is nice. This is amazing because it is doing the thing that happened last time when we tried this out, and we liked this effect. We liked this filter precisely because of this. We were using RGB24, so it's not a surprise that BGR24 does the same. Again, I think that BGR is just RGB reversed, but it has this effect where the melodica is changing colors. I guess my shirt is also changing colors. Everything is changing colors. I love this. It seems safe to say that all the pixel formats succeed. None of them throw an error. And it doesn't affect the performance a whole lot. It seems like it affects the performance when there are fewer bits, which makes sense. But other than that, I wouldn't expect the performance to change because we are looking at the bits or the bytes. All of them work, which is okay, good. I wondered if perhaps some pixel formats wouldn't be supported by the raw codec, but it seems like all of them are. They do give you different interesting results, and none of them are boring. So overall, I think that we may just ship with all of the pixel formats. And it is true that some of them are similar, but they are not quite exactly the same. And so what, right? We are going to be combining not multiple pixel formats. We are going to be combining pixel formats with filters with this and that. Let's look at this one, though. It doesn't get old. It is always awesome. This is probably going to be similar because the only difference between these two is the big endianness versus little endianness. But they are quite exactly the same, I think. Ooh. 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 I like how it goes between just me and the crazy colors. And I suppose that and this may be something that we may want to look into. Right now, we have a bit rate on the way in, and we copy that bit rate on the way out. Let me show you what I mean by this. When encoding this is what I mean. We get the bitrate of the original file and we use that bitrate on the output file. But most data bands are going to be more interesting than the inputs. Usually you have an input that is relatively boring, just me in front of a dark black background or something. And then the output is going to be these crazy colors. So while it is true that the bit rate of the input was good enough to have a reasonable quality, maybe the bit rate of the output should be higher because we do see lots of blocky artifacts because of all the crazy colors going. You can really see the codec struggling to encode my face, which is not half bad either. Maybe we could incorporate this in the band and have that as a possibility. Because I would just take note of this then. Well, I guess this to-do covers it. So maybe you will have the blockiness of the codec. You can tell that this frame was a P frame or a B frame, and this was an I frame because it gets sharp again. And then it's going to degrade, get blocky, bunch of P frames, and it doesn't get better. But yeah, when it gets colorful, it gets blockier, 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 blockier. Bunch of P frames and B frames. And then, bam, I frame. Yeah, this is sharp. This is not. Fun stuff. Let's continue. Oh no, I closed the file, so I don't know where I was. Okay, this is the little endian version of the previous one. And it looks about the same, yeah. For some reason, I am more okay. I love the data bands. Oh, this is amazing. I am more okay with the craziness of the data bands than the blockiness of the lower bit rate. I know that it may add its own charm to the whole situation, but it just looks lower quality when the bit rate doesn't keep up with all the color changes. This should be my avatar. Red. These are all variations on the same theme. Let's scroll through a bunch. Oh, this is interesting. I was going to say that this pixel format wasn't doing anything, but it's doing something. It's doing something. Let's look at this again. It's so different. This is amazing. The more I play with this, the more I like data banding. Such a cool art form. And why does it sometimes flicker back into my face? My regular face, not the garbled one. Oh, and this is sort of combining with this one, because it makes sense, right? They are the same pixel format with different number of bits. Oh, I love this. I'm probably going to run out of disk space because we have many files going on. Oh, it's over. It's over. How many files do we have? That is not right. Each file is about 1 megabyte. The whole folder is just 200 megabytes. That's okay. Thought it was going to be much more than that. So before we scroll past and lose all this precious, juicy data that we created, let's drop this into the README. And we have the pixel format, and all of them succeeded. Awesome. And then the duration. Let's look at more of these, and that is the rest of the stream today. That song and video live stream will never leave my nightmares. Yeah, you should go to, I think it was in Aria's channel, IZQD Sound. If you're watching this and you haven't watched those videos, you should check the song. It's super cool. Are you processing raw video or compressed? Because I was thinking there might be a new keyframe when the red starts. I am processing the raw video. So the way it works is I take the MP4, I convert that into a raw file that is no headers, no metadata, no nothing. It is just the bytes that represent the pixels. So it's just RGB, RGB, and so on. I process that pretending that RGB is actually A-law or mu-law encoded PCM. And then I convert the results of that back into an MP4. That's how this works. And the reason why I do it this way, why I convert into raw video, is precisely the headers, the metadata that exist in compressed videos. So when you compress a video, you're going to be using a codec, and that codec is going to store things like metadata, like this is a P frame, this is an I frame. And that sort of metadata doesn't play well with data bending. When you bend the metadata, you end up with a corrupted file or a corrupted video stream within a container. So that's why I convert to raw, and I always process raw. And yeah, there might be a new keyframe when the red starts. That may be true. It may be some artifact of the encoding. As we saw, we have artifacts of the encoding. The thing was getting blockier. Yeah. All right, let's move on. Amazing! Again, getting blockier and blockier and blockier still. What the hell? But this is crazy. Now there you have it. You will have a tool that you throw videos and you get this out. What is not to love about this? So different. The pixel formats are making perhaps a bigger difference than the effect itself. I wonder if all the filters respond to different pixel formats like this. This is so cool. It reminds me of a cover of an album. I think it is the latest Foo Fighters album. Yeah, it reminds me of these effects. More of these, actually. Yeah. Reminds me of that. This is so cool. We saw some of these before. The GBRP is similar to the GBRAP, which I guess is just the alpha version of that. Okay. Gray, I skipped some, by the way. I skipped the ones that are probably going to be similar just because it's using different endianness or different number of bits. But the gray one is not terribly nice. Maybe if we were doing something other than this filter, because you can sort of see that there is the next frame is sort of peaking here on the right, so it's not doing just our grayscale conversion, it's doing something as well, and even that point where it jumps goes left and right. So I suppose that with some other filter this could be more interesting, and this is already cool. All right, these are the grays. This is the halftone thing that I was talking about. This is so cool. Oh, man. Again, same story. And I'm turning blue. And I'm jumping left and right. Yeah, this one is kind of garbage. Oh, it picks up in the end. Okay. It's interesting because the only thing that changed is the endianness, but this one is more interesting. Go figure. Guess big endianness with this kind of encoding is going to be garbage. But then in the end it picks up, so I'm not going to exclude it from the list. Ooh, okay. I guess we are getting green here because probably if the format cannot make sense of some byte, it's going to interpret that as green, which is something that happens in some pixel formats, I think. It's either going to be green or purple. But I don't hate these ones. And I guess they pick up in the end? Nope, they stay garbled. Now we are getting back to RGB things. We saw this. It's going to turn red in the end. Ooh. Ooh. You know what I may be doing wrong? I'm keeping the bit rate. Perhaps what I should be trying to keep instead is the quality. We could have some constant quality situation. That may be the way out of this problem. Okay, we have some RGB stuff. We already know what that looks like. UYVY. Okay, we sort of been here. Colors changing. Okay. Same, but in black and white, and my face is more distorted. And this is the pixel format that you see most often. This is the pixel format you are looking at right now in this stream. I think that that's the pixel format that YouTube uses. It isn't terrible, but it's not the most interesting one. Then we have tons of variation on this. Whoop, 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 whoop. Goes from normal to crazy. Same, but with alpha this time. That's what the A stands for, transparency. What a ride. Yep, lovely, lovely, awesome. Yeah, okay, that was a fun exploration. We looked at many pixel formats today. We have a lovely table of all the pixel formats, and let's see, some of them remind me of the picture of Trevor Horn on the front of the Buggles album, The Age of Plastic. That does not ring a bell. Can I get the cover? Yeah. It's not too far off. I think that the tremolo effect does this. We were using the A tempo effect, but I think that the tremolo effect does something more like this. I just had to listen to Video Kill the... Okay, that I know. That rings a bell. Video Kill the Radio Star. First song to be played on the MTV, if I remember correctly. On the MTV in the US. All right. That was a lot of fun. If you want to play with this yourself, you can go to the link in the description. You will find the GitHub repository with the code that we just pushed. And you can play with this with your own footage. Isn't that fun? Some of them remind me of the Marquise Brownlee video where he re-uploads a video to YouTube 1,000 times to test how YouTube compression affects the video. Yeah, I haven't seen that one in particular, but I have seen experiments of this sort, and the compression artifacts degrade the picture. I don't think that they go as far as the wacky stuff we saw today. I'm so positively surprised by the effect of the different pixel formats. It is amazing. Anyhow, I think it's time to wrap up for this year. What a ride. So yeah, let's reminisce a little. We worked on a library for JS effects that isn't really finished, but we do have a couple effects using the library, and they do things that no other effects do, so that was fun. We worked on Kill the Newsletter, we worked on several songs, we worked on this data bending stuff, probably other things that I forget. We worked on Cacha this year, I think, this application that allows you to build a Node.js app into a single executable binary. That was a lot of fun. And we will get back to it next year. Yeah, so for next year, I think I will not be able to stream every day of the week, unfortunately. It is very sad, but I don't think I will be able to stream every day of the week. I may do 2 times a week, maybe once a week. I will be working on some other things on the side, hopefully more shorts and other explainer videos. That's the plan for next year. For the time being, thank you very much to Not Was One, Mage, Ben, and Dale for being here on the chat with me. Happy New Year to all of you. And thank you to everyone else who is usually on the chat, maybe not here today. Bo, Foti, Siwitz, everyone who watches this and is not active on the chat. You just watch this and you find it interesting and you don't say anything. It's fine. I appreciate you being here. And I look forward to next year doing more wacky, interesting stuff with audio, video, web development. We'll probably get into some more C++ next year. It will be a lot of fun. Thank you all for being here. Have a happy new year. I see you probably on Monday. Yeah, Monday is the 2nd, right? Yeah, I will probably see you on Monday. Bye. Thank you for watching the stream. You know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And so we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.